Hello everyone. In this video, we will be discussing how to allow possible bad outcomes in present value estimation. We will start with an example. Project Jet produces just one cash flow, which is the most likely cash flow for this project, as $1 million in year one. And it's considered to be an average risk project, which can be discounted using a suitable discount rate of 10%. Now 1 million divided by 1.1, and you can see present value is $909,100. But now you discover that the company's engineers are behind the schedule in developing the technology required for the project. They are confident that the project will work. However, there is also a small chance that it may not. So still the most likely outcome is $1 million. However, there is also a small chance that the project may not generate any cash flow. So you can see that 22% possibility that the cash flow will be 1.2. So the most likely cash flow is still 1 million. 22% possibility that it will be 0.8 million. However, there is a small chance, 10%, that the project will generate a zero cash flow. And now, considering this riskiness of the project, the unbiased the forecast of the cash flow is 900,000, which previously was $1 million. And we use the same discount rate. You can see that although riskiness of the project increases, we are using the same discount rate. The reason is we have already incorporated the riskiness in the cash flows. So the present value of this project is 818,000, which previously was 909,000. So you can see that although we previously learned that the project's riskiness can be incorporated by adjusting the discount rate, here we see that the project riskiness can also be incorporated by adjusting the cash flows. Look at this example. Now, this is an example of incorporation of risk in cash flows and in discount rate. First of all, this is the originally cash flow estimation, 1,000 every year, and present value at 12% is this. Okay. Now it's just assumed that the original cash flow was very much optimistic, so management decided to reduce it by 10%. So this is the correct cash flow. So you can see previously it was 1,000, now it declined to 900. So cash flow is reduced by 10%. So we use the same discount rate since the riskiness is already incorporated in cash flows. We use the 12% discount rate to discount cash flows. You can see previously the present value was 892 and now it is 803. And if you find out the present value correction, it is 10%. So the cash flow declines by 10% and so is the present value correction. I mean the present value of the cash flow also declines by 10%. Now, if you think other way that since the project cash flows are too much optimistic, so let's increase our discount rate by 10%, what happens? So previously our discount rate was 12%. Now we increase this to 22% and discount the original cash flow, which is 1,000 by 22%. We get it 819, 671, and so on. If we calculate present value correction, you will see that it corrects 8.2% in the first year, 15.7% in the second year, 22.6% in the third year, 29% in the second year, and so on. And in the last year, it's 72.3%. Okay, so although we increase our discount rate by 10%, however, our present value correction is much higher in the distant futures because the distant cash flows are affected very much by the change in the discount rate. So you can see that when we incorporate risk in capital budgeting and we assume that the project cash flows are too much optimistic, it's better to reduce the estimated cash flows rather than adding any fudge factor in the discount rate, because increasing the discount rate for a certain cash flow issues will have a very severe impact on the distant cash flows. Now, there is another way of incorporating risk In practical capital budgeting, you know that a single risk-adjusted rate is used to discount all future cash flows. This assumes that project risk does not change over time but remains constant year in and year out. We know that this cannot be strictly true for the risks that companies are exposed to are constantly shifting. We are venturing here onto somewhat difficult ground, but there is a way to think about risk that can suggest a route through. It involves converting the expected cash flows to a risk-free cash flow or certainty equivalence. So first we work through an example showing what certainty equivalents are. Then as a reward for your investment, we use certainty equivalence to uncover what you are really assuming when you discount a series of future cash flows at a single risk-adjusted discount rate. So look at this diagram first of all, and a discussion on certainty equivalent method. This is basically can be done in two ways. You can see, first of all, we already know about this. We discount the risky cash flows by a risk-adjusted discount rate, which is greater than the risk-free rate. And this is illustrated by the clockwise route. Okay, so we have a risky cash flow, we discount it by a risk-adjusted discount rate. But what we are now arguing is we can convert the risky cash flow into a certainty equivalent cash flow, okay, or a risk-free cash flow, and discount it by a risk-free discount rate. So which is illustrated by a counterclockwise route. To see a numerical example, project A is expected to produce cash flows of $100 million for each of the next 3 years. Given a risk-free rate of 6%, a market premium of 8%, and a beta of 0.75, what is the present value of the project? So to find out the present value, first of all, we need to find out the required rate of return, and we use the CAPM. You can see risk-free rate plus beta into market risk premium. Risk-free rate was 6%, beta is 0.75, and market risk premium is 8%. So we can see that our required rate of return is 12%. Now, as we have $100 every year, so we discount them by 12% and we get a present value of 240.2. So this is the present value of the cash flows. Now we assume that the cash flow changes, but they are risk-free. So what's the new present value? So what we can do is, these are our uncertain cash flows or risky cash flows. Now since the cash flows are risk-free, what we can do is we can convert this risky cash flow into risk-free cash flows, or the risky cash flows into certainty equivalent cash flow. For example, this $100 is converted into 94.6, this $100 is 89.6, and this $100 is 84.8. So risky cash flows are converted into risk-free or certainty equivalent cash flows. I will show you how we do that. And these risk-free cash flows or certainty equivalent cash flows are now discounted at a risk-free rate instead of the risk-adjusted discount rate, and you can see that the present value is 240. So either approach you take, present value remains the same, because in the first case your risky cash flows is discounted by a risk-adjusted discount rate, whereas in the second case your risky cash flows is first converted into a certainty equivalence and then a risk-free discount rate is used. So the present values will be the same. Now you can see that $100 is converted into 94.6, and since this is the risk-free, this is called certainty equivalent cash flow of $100. Now look at how much we reduce for risk. So $100 is reduced to 94.6, risk reduction is 5.4, and $100 is converted into 89.6, reduction for risk is 10.4, and $100 is converted to 84.8, so the reduction for risk is 15.2. And you can see that as the cash flows are coming in the distant future, the deduction for risk is higher. It's pretty much logical, because the distant the cash flows is more uncertain we are, the more risk involved. That's why the deduction for risk should be higher. Now, how we find out the certainty equivalent cash flow? You can remember that $100 was reduced to 94.6, so it reduced by 5.4%, which can be taken as an annual factor. So risky cash flow is divided by 1.054, which lead us to certainty equivalent cash flows. So you can see $100 is divided by 1.054, so it's 94.6. $100 is divided by 1.054 square, so 89.6, and $100 is divided by 1.054 power 3, so 84.8. So these are the certainty equivalent cash flow, and you can see that although we are using the same annual rate, since we are using the power for the distance in the future, so the cash flows in the distant future will be reduced more for the higher risk involved in the longer term. So that's the end of our discussion this week. Don't hesitate to let me know if you have any problem understanding any of the topic. Thank you very much.